Hello, my name is Victor Eduardo Peñamontes, and this is Project 1 for the class of MECH 1321 for the University of Texas at El Paso. This project will go over the statics and dynamics of the following structure: a light post held to the ground. We will perform a 3D diagram in which will be included the knowns and unknowns, the free body diagram, and we will also formulate our assumptions for dimensions, weight, and wind loads applied to said structure. But first off, what are the wind loads in Ciudad Juárez, El Paso? According to the National Weather Service, the peak recorded gust in El Paso's history is of 84 miles per hour on two different dates in history. The dates being March 10th, 1977 and March 26th, 2010. For this project, I'll be using El Paso's wind records since both El Paso and Juárez are both virtually in the same region, as well as the data not being properly recorded for the Juárez area since 1985, thus not making it proper for this project. What are the knowns and unknowns? The knowns are, of course, the wind speed, which is 84 miles per hour, gravity, and the normal force. Our unknowns are going to be the wind load, the surface area, the dynamic pressure, and the density of air. Our free body diagram here denotes the X, Y, and Z axis, the normal force, gravity, and the wind force. The assumptions that will be made for this project are that the beam is hollow, the beam is made of steel, we will just be accounting for the beam itself, not the concrete base, that it is on an open field, that the foundation is correctly made, and we will not consider forces such as drag and others, since this will create a much more complex calculation, and this is just a simulation. To find the wind speed. Finding the wind speed, we of course reached for it, and we got 84 miles per hour, which is 37.55 meters per second. Finding the air density. To find the air density, we will use the chart as well as the average temperature of the day in which the highest wind speed was recorded. In this case, it would be in the month of March, since it's when the highest wind speed was recorded twice in El Paso's wind history, meaning that the average temperature will be 23 degrees Celsius, which will get us the density of air 1.192 kilograms per meters cubed. And this is said graph. For this project, I used the software Autodesk Fusion 360, provided by the Mechanical Engineering Department, in which I model a light post as close to the one that we're doing in the calculations. With this model, we can get both the height and the radius. To find the total surface area, we will be using the guess method. G is given, which gives us the height, the radius of both the bottom and top surfaces. U denotes unknown, which it's lateral surface area, the top surface area, and the bottom surface area. E denotes the equations, which are going to be the equations that we need to solve for L, T, and B. The first S denotes solve, which is how we get to the total surface area, which is going to be L plus T plus A. And the final S denotes total surface area, which is going to be our final answer, of course, which is going to be 2.63 meters cubed. Following are the models. It's the model that I created on Fusion 360, which gives us the height, the bottom radius, and the top radius. The wind load calculation, we use the wind load formula, which is 1/2 times density times wind speed squared times the area. We then plug in our values from the previous exercises, and then for our final answer, we get 2210.15 newtons. Wind load calculation comparison. For this project, what I decided to do was to compare it to what it would take to push someone out. And according to a page that we found on Mapleton, the required wind speed to knock someone over would be 31.3 meters per second squared. So for that, we plugged it into the previous equation, and we finally got 1535.64 newtons. Now we have both wind loads, we can compare both loads like the following equation. 45 kilograms over 1535.64 newtons equals 100 kilograms, which is the average weight of the light post. And then we solve for the bottom force, which is going to give us 3412.53 newtons. So in conclusion, with information that we have now gotten, we can conclude that the post will not fall if the wind speed were to reach such high levels again. Since the needed wind load to not cover the light post is 3412.53 newtons, and the highest wind load recorded is of 2210.15 newtons. Thank you for hearing.